Today, let us discuss relational database design using to relational mapping. So, in to relational mapping algorithm, we have 7 steps. Step 1, we will be mapping all the regular entity types into a relation. When I say relation is nothing but it is a table. Informally, we call a relation as a table of values. So, in a diagram, which all regular entity type is there, that we will be converting into a relation. Then next we move on to mapping of weak entity type. So we will search for a weak entity type is represented in the diagram or not. If at all it is there, then that also weak entity type also we will be converting into a relation. Then we will be mapping for binary 1:1 relationship type. In the diagram, we will check out it is relationship type. In diagram, we check out is there any 1:1 relationship type. Okay, if that is there, we will mapping that and binary 1:1 relationship type. Then fifth step mapping of binary 1:1 relationship type and step 6 mapping of multi-valued attribute. And finally, in the diagram, we'll check for any n array relationship type. When I say n array relationship type, it is nothing but in a relationship type more than 3. Okay, more than 2 more than 2 entity participating. That we call the n array. Okay. So let us consider the company database. Okay, company database. We have a employee, we have a department, we have a project and dependent. In this diagram, okay, we discussed in the previous classes what is this company database. Okay, how to convert the requirement document of a company to a diagram. Okay, that is design phase. In the design phase, how the requirement document will be converted into a diagram. So if you see this diagram, we have regular entity type, we have weak entity type, we have attributes for each entity type. Then we have 1:1 relationship type, and we have 1:n relationship type, M:1 relationship type. All okay, M:1 relationship type. All varieties is there. Recursive relationship type. Every concept is covered in this diagram. So let us consider this diagram as an reference or an example to discuss our to relational mapping. Okay, relational database mapping. So here you can see this in this diagram. You can see that we have entities like employee, department, project, and weak entity like dependent, and there are relationship whichever it is given in the rhombus that we called as a relationship type. Right? We have relationship like type like works for, managers, controls, dependent of. Okay, so works on and supervision, these are the relationship type. Okay, so in this relationship type, how many entities are participating? Based on that, we call it as binary. Okay, binary. If the entity is more than two entities are participating in a relationship type, we call it as a ternary. Okay, ternary. More than that means again it is n array. Okay, but here in this diagram, we have only binary relationship and unary relationship. Binary relationship means what? If you take works for, managers, controls, works on, dependent of, all relationship it having maximum of 2 entities connected to it, right? So this we call it as a binary relationship. Works for, it is having employee, department. Then managers, it is having employee, department. But the cardinality ratio is here n:1 for works for, but the cardinality ratio for managers is 1:1. Okay, then for works on, we have binary. Works on is also a binary relationship which is with the cardinality ratio m:n, and control is also association binary relationship which is having the 2 entity participating in it, that is department and project, with the cardinality ratio 1:n. When we come to dependent of, actually it is a weak entity type. Okay, it is a association of weak entity type with its owner entity type, that is employee. So weak entity type is dependent, okay, which will be always connected to its owner entity type, okay, and it is also having 1:1 cardinality ratio. So when I come to a relationship supervision, supervision actually it is we this type of attribute we call it as a this type of relationship we call it as a unary relationship. Why? If you see here, if you see works for, here employee and department, two different entities are connected to it, right? When you see this supervision, it is connected only both the side of this supervision relationship, only employee is connected, only one same entity is connected. So that's why we call this association or this relationship type as unary relationship type. Okay, whenever we have a unary relationship type, we should be very careful that we should give the role names. Okay, unary relationship type or self referencing relation. Okay, self referencing relationship. What is self referencing relationship? That means a recursive relationship. We call it as a recursive relationship. Okay, self referencing self referencing relationship or recursive relationship. What do you mean by self referencing or self what do you mean by recursive relationship is means, okay, two or more entity participating in a particular relationship with different role names. So that's whenever we are using the unary relationship, we have to give the role name separately. For other things, the role names are understood by the entity name itself. Okay, but whenever we are whenever we are drawing the unary relationship, then we have to write the role names because only one entities are participating into this relationship, and this entity is of different roles. One same entity is participating but in a different roles, okay, different character. So that's why we have to mention the role names here whenever we are dealing with the unary relationship. So this is actually the ER diagram we have. Every entity is having their its own attributes. So if you take name, okay, if you take name, name is having. If you take the attribute of employee name, name is subdivided into first name, middle initial, last name. Yes or no? First name, middle initial, last name. So here, this type of attribute we called as a composite attribute. So if you take department, there is a in a requirement it is clearly specified that department can be located in multiple location or several location. Several location is what it is having many values. So this is multi-valued attribute. That's why it is written in a double oval, right? So we have to deal the multi-valued attribute. We have to deal with the composite attribute. Okay, all the relationship type and all the entity types. Fine. So you can see here on the works on relationship, we have one attribute attached to it, that is hours. Okay, hours. For managers, there is one more attribute attached to it, start date. For department, there is a derived attribute with the dotted oval, that is a number of employees. Okay, number of employees. So it is not that always we have to attach the attributes to the entity only. No, it is not like that. In some situation, it will come that that attribute is a combination of both the entity. Okay, it is a combination of both the entities. So if I keep any one side, it will not be fulfilling that meaning. Okay, so I have to attach such attributes to the relationship type only, which will be having the value which is a combination of both the left side entity and the right side entity. Okay, or left side relation or right side relation. So this is start date. Okay, and start date is actually talking about the employee start date as a manager. So when I give start date here, it will be just talking about the employee start date. Employee start date and that employee became manager and started two different things. So no, start date it is like employee joined to the freshly to the work. So the start date will be like August 1st, 2018, like that. That may happen, right? But I don't want that. I want the how when that employee took in charge as a manager, in charge as a manager. So if I put start date, it will be like for every employee it will imply. If I put start date for the department, it actually tells about the start date of the department. but I want the attribute which is a combination of both employee working as a manager in the department, start date of the employee working as a manager in the department. So I will be having the answer only for that. So when I attach to the managers, okay. So we will see how we have converted that ER diagram to relational schema. So the output looks like this, okay. When we convert the ER diagram to a relational schema, the result will be looking like this. You can see we have an employee entity, we have a department entity, we have a department location entity because it is a multi-valued attribute. So we have a project entity, we have works on entity, and we have dependent entity. Okay, dependent entity. So accordingly, whatever is given in the ER diagram, we will write we will write each relationship. Okay, each relationship, and we will add the attributes of that relationship. We will add the attributes of the entity. Okay, we'll create the we will create the relation and we'll add the attribute of that particular entity. Employee relation means employee entities attribute we will add to that relation. Department relation means department entities attribute, entity and entity attributes we will add to it. Okay, like this we will be keep on adding the attribute. Then we will be showing which table is linked to another table, like this using the arrowhead. Okay, that we call it as a referential integrity or foreign key. Foreign key. Okay, so this is how the mapping looks like that. This is how the mapping look like that. Okay. So this is the final output. We'll see how it is step by step. So as I told before, first step that what we have to do, we have to map the regular entity type, right? So when we see the ER diagram, when we see this ER diagram, so what are the regular entity type we have? We have the regular entity type employee, right? We have the regular entity type department, and we have the regular entity type project with the corresponding attributes to it, right? So here we have a set of attributes for the employee, we have a set of attributes for the department, and we have a set of attributes for the project, right? So in this, we some of the attributes are composite attribute. In this, some of the attributes are composite attribute. In this, some of the attributes are multi-valued attribute. Okay, like that we have to take it. And here we have two candidate key. Yes or no? Here also we have two candidate key. Okay, candidate key here name and number is underlined. That means name is one candidate key, number is also one candidate key because both have its own uniqueness property. Here name is also number of candidate key and number is also one of the candidate key in the department table. Then we have a derived attribute that has to be written using the application program to fetch the count of the employees. So this we have to how to handle this. So we have this one. So first what we have to map the regular entity type. When we map the regular entity type, okay, when we map the regular entity type, first what we have to do here, okay, here we have to create a relation for each regular entity type, right? Regular entity type, and we have to write the attributes and we have to specify the key attribute. If any of the attribute is a composite attribute, then we will be writing the subpart of it attribute, not that attribute, okay, main attribute. Then if there is a low multi-valued attribute like location, we will be using different different method to deal with it, okay, or represent it. So what according to the ER diagram, company ER diagram, we got to know that there are three regular entities. One is employee, department, another is project. So we create a corresponding relation for that employee, department, project. Okay, employee, department, project. We create a separate relation for that. Then we will write all the attributes which is there in the ER diagram. So here instead of name, it is written here first name, middle initial, last name. Why? Because name is a composite attribute. So we have to take the basic attribute only, basic level attribute only. So I'll go for the subparts. That is first name, middle initial, last name. So this is the composite attribute. Together it is called as a name in the ER diagram. Okay, but we have to always take the simplest because atomic in nature. Okay, the values of attributes are atomic in nature. So we'll take this Then SSN, so it is underlined as a key attribute. So I'll underline here. So birth date, address, sex, salary. So these are the attributes of the employee. Similarly, attributes of the department name will be written D name, D number, where D number will be underlined. Okay, so in the design phase, we had two attribute D name and D number underlined as a candidate keys. Okay, whereas when I come to the implementation part, relational schema, well, there can be only one key for a relation. Okay, there can be one key for the relation. So one among the candidate key will be selected as a primary key. Same thing here also. Project number and project name both are having key attribute qualities, right? But one among the P name and P number will be selected as a primary key. So P number is easier. So P number will be selected as a primary key. So here I have currently converting the regular entity type into relation. So that's why there is no connection showed yet in this slide. Okay, or the foreign key constraint that is not shown in this diagram. We are just converting the regular or mapping the regular entities from the ER diagram to a relational schema. So we map it like this. Okay, so next what we have to do, we have to go for the weak entity, right? So weak entity, what we have to do in the ER diagram, company ER diagram, we have one weak entity called dependent. Yes or no? Dependent with the set of attributes like name, sex, birth date, relationship. So for the weak entity also, we'll create a separate relation like dependent. Okay, dependent. But one thing we have to remember that should always enter, or we should always enter the primary key of a owner entity. So you can see here, dependent is connected to employee. Okay, dependent is connected to employee. Okay, employee is already converted into a relation. In the previous slide, I told. Okay, employee is already converted into a relation, but it is having another entity called dependent, right? Okay, another entity called connected to it called dependent. So I'll write dependent and all the attributes whatever mentioned here. Okay, dependent name, birth date, sex, relationship, everything I'll write. Okay, everything I'll write. Now how I'll show this connection? Okay, this dependent is under this so and so employee. This dependent is under so and so employee. So how I can connect it? Connect it by using a concept called foreign key. Okay, by using a concept called foreign key. What is this foreign key? Foreign key is nothing but we have to put the okay, we have to put the primary key of another table as a foreign key here with the same data type, with same domain, okay, with same size of the data type. Everything should be followed. So here we have dependent is connected to employee. What is the primary key of employee? SSN. Okay, SSN. So I will include SSN here. This SSN acts as a foreign key which refers to the employee SSN. Okay, it acts as a foreign key which refers to the employee SSN. Okay, so that's why you can see here we have an arrowhead here. So the value whichever we are taking in from ESSN is the value which is from the SSN of the employee. Okay, so SSN of the employee. Is it clear? Okay, this ESSN I have given the different name. This ESSN always refers to the SSN of the particular employee. Okay, so this is how the key attribute weak entity. Okay, weak entity is taken care. So we discussed the 1:1 binary relationship. So 1:1 binary relationship. Whenever till now we discussed about the mapping of entity types. Okay, mapping of entity type, whether it is regular or weak, that is. But mapping of entity type. Next we have the mapping of relationship type. So whichever you see in the rhombus in the ER diagram, that is relationship type. Okay, the relationship type means it is association of two relation. Okay, two entities. Okay, association of two entities. So here to map the binary 1:1 relationship type, we have different approaches to map the relationship type to a relation. We have some approaches. What is the first approach? Foreign key approach. Second is merged relation approach. Third one is cross references or binary relationship cross references or relationship relation approach. So what is this foreign key approach? Foreign key approach means what? It is most commonly used approach. Okay. Foreign key approach means what? Here we will be having two tables. Okay. We will be having two tables. Say for example S and T. Okay. S and T. So here foreign key approaches means whenever we say 1 is to n and one side is total participation considered, another is partial participation considered. So towards both are 1 1. Cardinality ratio, both the maximum participation is 1 1. Okay, both are 1 1. So that time we have to add the foreign key constraint. That time we have to go for foreign key approach. Before that, what we have to do, we have to check the this one we have to check the participation constraint, whether it is a total participation or partial participation. Any of the entities having total participation, okay, total participation, towards that we will be putting the foreign key concept. Okay, so here that is foreign key approach. So merger relation approach, merger relation approach, as the name itself tells, that merger relation approach is nothing but merging the relation. Okay, merging the relation. So merge the two entity types and relationship type into single relation. Okay, merging everything into a single relation. So this is possible when both have the total participation. Okay, that is based on the number of tuples. Okay, total participation based on the number of tuples, that both are having equal number of tuples, no issues. So next we another approach we have is cross reference or relationship relation approach. This is basically we use for m is to n cardinality ratio. Okay, m is to m is to n cardinality ratio, we will use this approach. So what this do, we will set up a third relation, new relation will set up, and we will add the primary key of associated table with that relationship. Okay, like works on is associated with to which works on is associated with the employee and the project. Yes or no? So what we'll do for the works on relationship, we'll take the primary key of employee and attach as a foreign key in that relation. Okay, in that relation, works on relation, and we'll take the primary key of project and attach as a primary key of a project and attach as a foreign key in the, okay, foreign key in the that that relation. Okay, foreign key. So in the two relations, so we have the both the side participating entities primary key we have. Okay, primary key we have this combination of this primary key, we'll just take it as a composite primary key for that table works on. Okay, that is like m is to n, we'll see with an example. So here any of these three approaches used, but most common approach is foreign key approach. Okay, most common approach is foreign key approach. So let us move on to, so here one is to one relationship. When we see the diagram, ER diagram company database, we have a one is to one relationship on the relationship called managers. Okay, managers with the cardinality 1:1, and it is also having the attribute. Okay, relationship attribute called start date. So here what we do, here we will already we have created the relationship for the employee. We already created the relation for the employee and relation for the department, and we have added the corresponding attributes. Right? We have added the corresponding attributes. That was we had done. So I have to show this. I have to show this managers. Okay, so managers relationship. Okay, managers relationship. That time what happened? What I do, I have to show. So if I want to use the foreign key approach, okay, foreign key approach, which side I should put the foreign key? That is the question, because 1:1, both are 1 1. So then I will go for total participation, whether it is a partial participation or total participation. Department is having total participation. So what I'll do, I'll add the primary key of employee as a foreign key in the department. What is the primary key of employee? SSN. So SSN is added as a foreign key in the department table. Okay, department table, and we'll attach the start date attribute, okay, attribute as an attribute to the department table. Okay, so this is foreign key approach. This will be called as a foreign key approach. So here we will be attaching this logical link. So when I say foreign key, it will make sure that the child table entry we should add only the existing tuple in a employee, and it should the domain should be same for both. Okay, same for both. This is how the 1:1 relationship is handled. So next we have the 1:1 relationship type. So whenever we have 1:1 relationship type, what we have to do? Again, we have to go for the foreign key approach. Okay, foreign key approach. So in the previous class I told you, right? So foreign key approach. When you see this diagram here, what you can understand? Okay, this is already done. Okay, this is already done. 1:1. So they are created a 1:1. Here we have created a foreign key approach. Okay, into the department table, and we have added manager and the start date, manager assistant and the start date. That is done. So next, what we have to do? 1:1. So we have the relationship type works on relationship type control. Okay, and relationship type dependent of we already mapped it. So no, it's foreign key. So we already mapped it. So we don't need to bother about this. We already mapped. We have to bother about works for and controls. This is also we have already done. Okay. So works for controls and super SSN. Works for controls super SSN. Works for controls super SSN. These are the 1:1 relationship type. So whenever we have a 1:1 relationship type, what we have to check? We have to check first thing is the 1:1 means first thing we have to here we have 1:1 relationship, right? So here 1:1 relationship is works for controls we have and supervision we have three different relationship we have. Okay, so three different relationship we have. So first we have to check out which is the relation or the entity towards the end side of the relationship. So towards the inside of the relationship, we will add a foreign key which will be referring to the primary key of another participating table, right? So here we have works for include the primary key D number of department as foreign key in the employee. Okay, call it D number. We can call it as a D number shortly. Okay, so supervision includes the primary key of employee as foreign key in employee itself. So supervision is referring to the same table, employee, right? So controls include the primary key department number of department in project, call it D number. So we just keep on foreign key approach, and we just include the foreign key in the another table, referencing table based on the cardinality ratio. Okay, cardinality ratio. So you can see here we have employee, we have department, we have project, and we have dependent. So these things we already created before only, right? But only we have altered or included some attribute extra. Okay. So here employee we added D number. Okay, which is employees belongs to this particular department. Then we have a project. For project also we have put the D number so that this project in this is related to this is referring to this attribute values, right? Then dependent it is owner entity is ESSN. We are added ESSN here, okay, which is having a constraint called referential integrity constraint of foreign key. So here it is a foreign key constraint, here it is a foreign key constraint. So wherever we have okay, wherever we have works for is a 1:1, controls is a 1:1, and we have supervision. Supervision is also 1:1, right? Supervision is also 1:1. So this attributes we have to handle. So for that we will use the foreign key approach. So what we do? We added that particular attribute, which is the primary key in another table. Okay, another table, and we just added and connected it. So here project, so D number, so it will be connecting. D number is an attribute on which referential integrity constraint is applied. Okay, referential integrity constraint is applied. That means it is logically connected to d number of a department table. Okay, fine. So this is how we deal with the 1 is to n relational mapping. Okay, mapping. So 1 is to n relational m is to n relationship type. So how to map the binary m is to n relationship type? So here in the when in the 1 is to n binary relationship type, there I discussed three approaches. What is the first approach? What is the first approach we discussed? Foreign key approach. Second is merged approach. Third approach is cross reference. Okay, cross reference or relationship relation approach. Okay, cross approach or relationship relation approach. So what is this relationship relation approach? Means a relationship relation approach means both the entity will be having maximum participation in the relationship, which is to which both the entities are joined. Okay, both the entities will be having the many to many participation, maximum participation. Both are maximum participation. In that case, we will be creating separate. Okay, we will be creating a separate table which will be containing that uh, primary key. Okay, primary key of the referencing or connected relation or the entity types. Okay, I'll show you this. So here works on. So as we know in the diagram, we have, as you can see here, there is a works on relationship with the cardinality ratio 1 is m is to n. Okay, and it is having the hours. Okay, so how I can represent this relationship type, which is having the cardinality ratio m is to n. So straight away you create new. Okay, you create new relation that is called relationship relation. Okay, relationship relation. Whenever the relation is having one m is to n. Okay, whenever the relation is having m is to n cardinality ratio, you can straight away create the new relation with that name. Okay, with that name and the connecting entities primary key. Which are the connecting entities? Employee. What is the primary key of employee? SSN. Okay, and which is the another entity participating? Project. What is the primary key of project? Project number. So I'll just add ESN project number, and here we have one attribute called hours, which is related to this relationship. So I just write hours here. Okay, I just write hours here. So whereas ESSN refers to the SSN of employee, whereas P number refers to the P number of employee. So next we move on to how to deal with mapping of multi-valued attribute. So whenever I just go for the multi-valued attribute, you can see double oval. It is implies the several location. Okay, several location. It implies the several location. So here one attribute is having multiple values. Okay, such attribute we represent using the double oval. Okay, that is there in the department location. So what happens here? We have the multi-valued attribute. Say, for example, when we take the company, okay, when we take the company, so here we have the department name, okay, department name and location. Suppose I'll keep the location in the same table where I kept the department number, department name, and the manager start date, manager, everything. Okay. So if I put the location in the department, say department 1 is having three location. Okay, three location. Bangalore, Mysore. Okay. So three locations. Let us say Bangalore, Mysore, okay, Gulbarga. Like this, the department 1 is situated in three location. So another will take department number 2. It is located only is Bangalore. Okay, Bangalore. So what happens here? There is multiple values for an attribute called location. There are multiple values for the location attribute. But what happens here when I enter DMG, it will take as a single value. That is what we call it as a domain constraint. It will catch up as a single value. Okay, single word DMG Bangalore, Mysore, Gulbarga. Together it will read as a single. single attribute value. Okay, so that time what happens here, suppose I want to know who are the employees are in Bangalore. This will not be fetched because this will be fetched, but this cannot be fetched because it is in a separate row. Okay, BMG, DBMS will be calling it as BMG rather than BMG. Okay, rather than Mangalore Gulbarga, it will be called as BMG. Okay, so this happens when we use the multi-valued attributes. Okay, this will happen when we use the multi-valued attribute. So how I can? This is again what is happening. It is happening again. It is again, it is considered as a one value, right? One value. But this is very important that every location I have to monitor. Okay, the data. Every location I have to monitor the data. So what I can do, since location is a multi-valued attribute, according to ER to relational schema algorithm, okay, according to ER to relational schema algorithm, we have to create a separate relation for multi-valued attribute. Separate relation for multi-valued attribute, and we have to keep a foreign key, that is, we have to connect the location to the department table. Okay, so we here separate relation for every multi-valued attribute. We are created a separate, okay, separate relation. Okay, so I'll show you. Yeah, see here we have a department. Okay, department is having a multi-valued attribute, that is location. So how to represent this multi-valued attribute? Multi-valued attribute, I'll create a separate relation. Okay, this is attribute. I have created a separate relation called department location. Okay, department location. So department location. So here, in the department location is a relation. So I'll make department number, department location together as a primary key, whereas department number is a foreign key of a. Okay, department number is represented as a foreign key which references to the department number of the department. So in this way the multi-valued attribute is maintained. Okay, in this way the multi-valued attribute is represented. Why? Because when I say Bangalore, Mysore, Gulbarga, this will be taken as a single value. Okay, this will be taken as a single value. But I want to keep track of the department in each location. Okay, department in each location. Suppose I just give like this. Suppose if I keep that like this, like department number, department name, then department location, okay, department number, department name, department location, manager SSN, SSN like this, manager SSN and manager start date, manager SSN, manager start date. What I will get the values like department number 1, name admin, location Bangalore, manager Dr. S. Okay, and here start date 23/1997, like this something. So again there is a location 1, admin, sorry, 1 admin, location Mangalore, manager, and SD. We'll write the date. That's on like this. Again 1 admin, location G. So what is happening here? We are violating the what we are violating? Violating key constraint. Yes or no? D number we are declared as a key. Then we are entering duplicate value. Yes or no? And you can see here all this data are redundant. Only this will be varying. All this data are redundant in nature. Right? It is redundant. So again wastage of memory, all this redundancy will come. So when I show it separately. Okay, what I'll do, I'll show it like this. Department number, department name, okay, department name, then again manager, manager start date. So here if I give attribute like location 1, I just write it as L1, L2, L3. That will be good for you, I think. Location 1, location 2, location 3, so on. Okay, location 1, location 2, location 3, so on. Okay, what happens here? Department number 1, D name is admin. Okay, D name is admin. And the manager is some person. Okay, then manager start date is 10th October 2018. Okay, so here location 1 is Bangalore, location 1 is Mangalore, location 3 is Gulbarga. Okay, like this I'll give. So what happens here? Number of attributes are getting more. Again, it is a tedious. Yes or no? Tedious. So like this, I have to keep on recreating. If there is 3 location is okay. 10 location means again it is a problem. I have to add as many as column for that each location. So what we can do better is here. So we can do like this. We can create a separate okay attribute, okay, separate relation for a multi-valued attribute. So here department location, I have taken department number, department location, because I should know which department is in which location, right? So department number and department location I'll take, and I'll take I'll underline both as a composite primary key, because department number alone is a primary key in another table. It is just linking. So department number, department location both will be considered as a composite primary key, where department number is having a foreign key construct which will be referring to the department number of the department table. So like this we will be dealing with the department location or multi-valued attributes. Next we have mapping of n-ary relationship type. Okay, n-ary relationship type. So what we have to do when we have more than two entities participating in a relationship type. Okay, so n-ary relationship type. So in that case, okay, in that case what we have to do, we have to go for a separate relation. Okay, separate relation. We have to create a separate relation for such relationship type. Okay, so let me show you the example. Here you can take the relationship supply. Supply, how many entities it is connected to? Supplier, project, and part. Okay, so we have connected 3 entities to this relationship type. Okay, there is one common attribute called relationship attribute called uh, quantity. Okay, so how I'll convert this type of ternary relationship or n-ary relationship to the relational schema by doing this, just by creating the entities, regular entities in a ordinary relation or a table. Okay, then that connection is stored by supply s name, supply s name, uh, project name, and part name. Okay, part number. Like this we will be, okay, like this we will be writing for the n-ary relationship. Okay, n-ary relationship type. It is all about whatever I am taking, 1:1, 1:n, m:/n. Okay, n-ary, all about the relationship type, that is in ER diagram rhombus. Okay, rhombus. So if it is having more than 2 entities participating in that, you can just go for like this when you are converting to ER to the relational database schema. So let us see the summary of mapping constructs and constraint. ER model, entity type. In ER model we called as entity type. Same thing we called as an entity relation. 1:1 and 1:n we represent using a foreign key in relational model. Okay, m::n we create a separate relation or a table where when we have a cardinality ratio, uh, okay, with the cardinality ratio m::n. So if it is 1:1 and 1:n, we will just go for the foreign key concept. Whenever we have a relationship type m::n, Then we have to create a separate relationship as we discussed in the cross referencing or relationship relation. Okay. Then NRE relationship type, we have to add a separate relation and add the primary foreign key constraints on the attribute. Simple attribute means it is just which is not divisible. Composite attributes means set of simple components attribute. Multivalue attribute means relation and foreign key. Value set means we call domain. Key attribute means primary key. Okay, so this is the difference. Okay, so hope you understood this. Okay, in ER model we call this terms, in relational model we call these terms. Hope you understood this.